resume recording. Okay, so I want to take your attention to the deadline, which is these couple of bullet points here. And again, deliverable number 1 is February 11th. That's being extended from today. Right, so it's next Tuesday. So a couple of things about these deliverables. We're going to practice a Japanese philosophy called Kaizen, right? Kaizen means continuous improvement and continuous integration, or also in the industry known as CI/CD. So how they're designed together, let me zoom in a little bit in case people can see. So how these things are designed together is to iterate on the previous draft of whatever idea that you can come up with. Now, of course, the very first draft, I will give you that, right? So hopefully after today's lecture, you have a pretty solid understanding of what goes into this draft of Python function, in a sense that if you have no idea what the project is about, if you know no idea what to do, hopefully after today's class, you have a pretty decent idea of what to do and what that function looks like in terms of structure, right? Like what goes into the function, what's happening in the function, and what comes out of the function. And then from the second deliverable, which is on the 18th, and then the next deliverable, which is on 25th, we're going to iterate on whatever we talk about in the first day, which is today, to talk about today's the day 1 for us to basically get started on project deliverable. And then we have 2 more iterations to iterate on that. And then based on past experience, once we talk about the first deliverable, like once everybody can that in, from the second one and from the third one, everybody's answer is gonna look very different. So there's not gonna be like correct answer or like what answer gets higher points. Like it's gonna be very difficult to answer those questions. So just try your best. As long as you can tie everything together, your code works. Your code like gives a score that follows certain rationale. That is good to go. And then another thing is, I'm obviously this is a letter grade, right? Obviously I have to give you guys a grade. So another thing is for me to understand that you guys learned something, which is basically I'll look at the difference of how much improvement you're able to improve from the first deliverable to the second deliverable, right? First deliverable, I will be giving you guys the solution. Everybody will be on the same page, right? So the second deliverable, obviously, hopefully, it's going to be better than that, right? If the second deliverable, like you're missing things, or your function is worse than the first deliverable, then obviously something's wrong. So that's how these things are designed together. And all the way to third one, obviously, we're going to see if we can put that in production, right? How we put in production is just give you guys a taste. Let's see. Where did it go? This one. So how it puts in production is if you download this app, it will give you a chatbot, basically a chatbot, and then you can talk to it. It will give you a list of reference, but the list of reference doesn't really have any score behind it. So we're gonna put in production. So when I say put in production, I'm talking about taking the function that you guys implemented and hopefully put it here. And then we're gonna see how user interact with that, right? If you give me a function and I put out on here, and then it's like a bug everywhere, it doesn't even work, then obviously that's kind of on you. Does that make sense? Or alternatively speaking, if you give me a function I implement in here, no one has to touch anything anymore, and then it just magically work. And then user use it, and then they're like, oh, this makes total sense. Like this blog is obviously false and the credibility score is low. That makes total sense. Then obviously you get a good grade. Does that kind of make sense? So we're gonna talk about the grading schema for this in maybe in like one more session. But today I don't want you to worry about that much about this part. I just want to focus just want you guys to focus on the idea of what goes into the function and what are some of the basic building blocks. And then on top of that, hopefully you guys get an understanding of like how to do the brainstorming session, like how to get the answer out of ChatGPT. There's like a unique way of doing prompt engineer to get the idea out of ChatGPT instead of you have to spend 5 hours do your own Googling and then click on a bunch of links and then read everything. So we're gonna use the first session to talk about that, and then the next session we'll take a break, and the next session we'll talk about logistic regression. And then I'm going to explain how those two things tie up to each other. Any questions? Good. Okay. All right. First things first, right? ChatGPT. So I'm a big fan of using ChatGPT in terms of doing brainstorming. What I mean by that is when you get a business problem that may or may not have a clear answer. In the old days, what I personally would do is go on Google and then type in a bunch of questions or keywords, and then literally just read every single thing, right? Is there a function that rates a URL? Is there a function that helps us understand the source and the credibility of a source? Is there a question to do whatever, XYZ, right? That would be what's happening in the old days. But fortunately, today we have ChatGPT. ChatGPT is internet data. Internet data goes in. Internet data comes out. It's really just a compilation of what's on the internet. So searching ChatGPT is kind of like a quick way of navigating all of the sources on the internet based on natural language. So it's very similar. I'm not saying ChatGPT is exactly the same as Google search. In that particular use case, ChatGPT serves as the same function as a Google search. So what are we doing here? We want to understand the credibility score, right? So first question I type in is, what are some famous algorithms that rate the validity of a chunk of string? Now, of course, the question kind of is provided by me, right, as an instructor. That's a project, that's the question we want to do, and obviously you start from that. One particular thing you do have to know is chunk of string. A website URL, it's entered into a Python function as a string, right? Because of HTTPS, www. Whatever, right? All those things are entered as a string. Obviously, number one is the number one topic you have to know is a string. So if you miss out on the string, like if you say enter a question that does not have chunk of string, the function might interpret differently, and it might put you on a tangent that doesn't really get you to that final function. Does that make sense? So every interaction with ChatGPT might put you on a derivation of answer, and you want to try to basically minimize that, right? The easiest understanding that the easiest analogy I can come up with is like if you guys watch Loki season 2, they talk about timelines. You want to make sure you're on the main timeline, right? You don't want to be the timeline on the margin, so you get pruned in the end. Does that make sense? It's gonna be a waste of time. And I'm gonna talk about how they restructure that data structure in ChatGPT. It's pretty obvious when you go on tangent. So it's a notable pattern that you can detect. So nothing really special is happening here. Literally just ask a very straightforward question. And then what you're gonna see is ChatGPT is gonna give you a bunch of topics that's in a bullet point that kind of leads to an answer, but kind of not, right? No one's talking about coding. No one's talking about how to implement this. This is just a list of topics that you could have Googled it, right? Regular expression, regex, okay, that's fine. We can talk about that. Checksum, hashing, okay, fine. Like, there are algorithms that turn a chunk of strings into chunk of numbers, right? We can also talk about that. And then you can go through these lists of topics, kind of just gauge your own understanding of what's out there, right? So immediately there's going to be a problem here, which is you may or may not understand every single topic in this bullet point. And frankly speaking, I don't understand some of this either. That's not a problem, right? Don't get blocked by some of these words here, right? So for example, like the long algorithm, right? No one's using that anymore. Like, you don't have to like get blocked by like what's going on in there. That may not be a problem. If you want to understand what that algorithm is doing, just open another ChatGPT window, just say what is long algorithm, and then it will give you an answer. So anyhow, how deep of a tangent you want to dive into, that's up to your own curiosity and your own time. But I want to make sure that you guys stay on track, right? Stay on track means how do you like digest and basically absorb these topics and come up with another question that puts you closer to the answer. So what I did here, and it gave you some nice table here, help you understand how to grade or how to rate a website URL, right? So these are ideas that you can probably think about. You don't understand everything, perfectly fine, no problem at all. Now you can say I have a use case. So this is gonna be so this is gonna put you on track of having ChatGPT trying to absorb what you're trying to do, and connect that with the famous algorithm out there. Does that make sense? So where does this thing come from? This thing literally come from like interaction of the chatbot, right? So you can take this question, and then I picked this question on purpose because you can actually get a sense that like why the chatbot doesn't work, which I thought was very interesting. So you can take this question, and then literally you can put it here, and you hit enter. You wait a little bit. What this website is doing is a mimic of that app I just showed you earlier on the other website. So what this app is doing is it's going to take this user prompt, make an API call to SERP API, and then whatever result SERP API gave you, it then send that into a large language model. Large language model will then intend to answer the user prompt using the content from the SERP API, basically from the Google search. So hopefully it's up-to-date answer, right? So if you go to ChatGPT, it'll probably give you something similar. But if you look at the reference, you also get a list of reference. So this is what I want you guys to think about. How do you rate this, right? So here's what's interesting about this question. I've just been on an international flight. Can I come back home to hold my 1-month-old newborn? Like I'm talking about, can I hold this baby, right? I'm not talking about, can I take this baby somewhere else? Does that make sense? But it turned out that if you do a Google search, the first link that pop out is traveling internationally with the infant. Well, that's not quite what I'm talking about, right? So you can kind of use this use case as an example to think about, hey, maybe sometimes the website itself has no problem. Maybe the website is just following the website's topic. Maybe the website is not lying. Maybe the website is still credible, but it doesn't really have anything to do with what I'm trying to ask. Does that make sense? So this is a kind of caveat case that hopefully in your function you want to capture. Does that make sense? So from using the chatbot, I have a use case. The use case involves a question and involves what I see from the chatbot, right? The answer, the URL, the reference, stuff like that. All you gotta do is type them down in ChatGPT. You say, hey, look, I have a use case. I have a prompt, right? The prompt is this, right? Put that there. And then I have a chatbot, explain a little bit what the chatbot is doing. You can just use this kind of language, say, hey, conduct Google search using SERP API, and then it provides LLM, related content, and then generates a response, right? Now, here's what the LLM says. Literally, you can just grab the response and put it down there in this whole thing. And then you put the source there. You say, hey, here's the source. Now you give the final goal, the final objective. Recommend some algorithm to rate this URL and the validity of the source. So if you just explain the situation well and provide this URL from your interaction with this search bot, you'll be able to come up with a pretty holistic problem statement for ChatGPT to figure out. So let me take a pause. Any question? Good. So now we have a question, right? Now ChatGPT is going to say something. Say, hey, look, to evaluate the validity and reliability of this URL, here's what you can do, right? It lists a couple of combination, couple of features here. ChatGPT is trying to come up. It says, hey, look, we're going to try to come up with a couple of different things, and then we're going to try to combine them. Now, immediately from here, you get the idea. You don't need to read the rest of it. Immediately from here, you're going to know that ChatGPT is going to give you some template answer, and you're going to have to improve upon it, right? Because there's no guarantee that this combination fits for the domain of questions that you're trying to ask, right? I'm asking this question today in class. Tomorrow, if I ask a different question, or if you ask a question, or if you ask a question, it's going to be very different from case to case. But that's okay. We're going to iterate that on the second deliverable or third deliverable. But the first deliverable, let's just get the structure out. Does that make sense? So let's take a look at the features. Well, number one, it's domain trustworthiness and scoring. And then it provides 2 algorithms. I think these are package names. If you don't understand what domain algorithm or what DA is, it's not a problem at all. Here's a concept here. You can read it. Me personally, I don't particularly read into these things because I prefer to look at the code and I will evaluate the code from that perspective. But in case this bothers you, of course, there's a concept here explaining what the algorithm is doing. Anyhow, that's one layer of factor, right? That's one layer of probability that the ChatGPT is trying to build to rate the credibility of the URL. So how trustworthy the domain is. And then number two is semantic similarity. Well, that's interesting, right? I never mentioned anything about semantics. I never mentioned anything about similarity, but somehow it's able to say, hey, look, I want to know if the content retrieved is even related to the question that you asked. Well, that's interesting, right? That's listed here in topic number two or feature number two, right? So great, ChatGPT is going to implement that. Let's let it do its work, right? So that's number two. Number three, this is what's really interesting, is fact checking. So apparently ChatGPT said you can make an API call and then you can kind of validate that the things that you say goes with Wikipedia or Google Knowledge Graph or whatever other things, other models that has database trained out there. Fine, you can do that. This could have a divergence from here. Some students might come to me and say, well, Wikidata is just Wikipedia. Anybody can go on Wikipedia and make your own edits. They can change the answer, they can change the facts. It may or may not be true. Fine, that's totally fair argument. But that's not what we're talking about here. What we're talking about is you have the ability in your function to verify and to come up with a score against certain database. The choice of exactly which one of them, or which two of them, or which three of them, or you say you don't like any of them, you can find your own, perfectly fine. No problem there. But the structure is here. It can be implemented in your function, right? So that would be number three. And then let's continue down the road. Source bias, same structure. Let's implement something new in the function that gives you source. Expert reference. This I think is going to make an API call to some sort of scholarly or peer-reviewed sites, so that it can kind of figure out a score based on a citation. Right. So it's a useful thing to have just in case it's not a blog, just in case like the ChatGPT finds some sort of paper or something like that. This function will be there to help you out, right? Now it's number five. I think that's pretty much about it. And then in the end, it showed you, hey, you can kind of combine a final score based on all of these five different layers of probability that we talked about. And then you can kind of think about them as features 1, 2, 3, 4, 5. Right? If you really want to, I can just call this x1, and I can call this x2, and then so on and so forth, x3, x4, x5. And then if you squint your eyes and stare at this equation a little bit, it kind of looks like linear regression model, right? So immediately now you kind of get the idea. Okay, so now all that stuff that we learned in linear regression model lecture can probably help out can probably help you out in understanding what's going on here. So now that you have a model, you kind of have a formulation of what this function look like. It's going to look like 5 API calls. Each API call can give you a score, and then combine them. One caveat I think you need to know is the weights. And then the weights at this moment, we don't have data to know what these weights are. The initial weights, you're going to have to basically randomly assign it. If you don't feel comfortable at all, then just do equal weights. 20%, 20%, 20%, 20%, but if you feel comfortable, you say, hey, I'm in a medical domain that I really, really, really want to make sure domain is trustworthy. And I have students that are doing grad school or PhD work using the chatbot. I want the citation score to be very, very, very robust. Everything else, I don't care. Certainly, no problem at all. You can make that assumption. I'll leave that to you guys. But that's fine, right? Point being, you can fine tune these weights as you move from one deliverable to another. Does that make sense? So now you have a structure. The rest is about implementation, right? So the next question is, okay, I like what you're talking about, right? I like what you're talking about. These are great features. If I want to build a Python function and generate the ratings programmatically, what shall I do? Is there API I can call? And then from here, you can probably stop there. But in terms of my own personal situation, I want to give you guys something that you guys can take home because this is a lecture, and then lecture needs to be reproducible, right? So I have to enforce it to come from Hugging Face, because Hugging Face, you guys can all apply for token. It's all free. If I download the model and you download the model from Hugging Face, there is a reproducibility. So I implement here, hey, you know what? Let's take everything from Hugging Face, right? And then whatever prompt engine is needed, give me some example. So now, of course, I asked ChatGPT for Python function then in the end, obviously give me a Python function, right? So end of this prompt, obviously give you a Python function. So let's just scroll down, take a look at this. Now, here's when things get interesting, and then how deep you want to go, and how much different divergence you want to take on, and how that's going to shape your deliverable too. It's going to be all come from here. So from here, all these packages, I already checked them. All these packages should be on Colab. If you're developing this locally, obviously, depends on your local setup. You may or may not have transformers locally in your laptop. If you don't have it, then obviously install it. But you can just make your life easier by going on to Colab, right? And then it actually gave me this nice function with all of the imports and essentially a main function called rate URL validity, right? And then it's all here. And then it has a doc string. You see these three double quotation mark here. This is called doc string. And then it helps me understand what the function is doing, right? Evaluate the validity of a given URL based on arguments. What are the arguments? User query, right? Whatever user typed in the chatbot. And then the URL is the link of a URL that ChatGPT gave you. Based on those two arguments, I then can give you a dictionary of different scores. So that's the structure that I'm looking for. And then we can go through this code a little bit, and then I'll show you guys how to implement it. And then there are also blanks, or maybe I can call it blind spots in the code that's not being implemented yet, that you can give you guys a chance to play around with it, right? So let's talk about this. Step number one is to fetch the page content. So this is kind of like the web scraping thing that we talked about last time, right? If I give a URL, you want to rate the URL, obviously you have to scrape it so you can look into it, right? And then I think last session, there's a question, if there's no link in the URL, what do you do, right? You don't have to go that deep. If you just scrape once, totally fine, right? If there's not a link in there, you don't have to scrape for a second time. So that's step one, is to get the content out of the page. Step two actually is a blank, right? It turned out step two is a blank. Literally just says 16. So it didn't even give us any API call, right? And I think the secret here is probably you have to get an actual key from Moz API, and that probably creates some sort of a blocker for ChatGPT to figure that out. So it literally just said, hey, this is just default 16, right? It didn't even attempt to check anything, right? So iteration 2, iteration 3 of the deliverables of project 1, obviously we can improve upon this. But I'm showing you guys this on purpose because it's okay to have a placeholder, to just have a number there and then to change it later. Step number 3, 4, 5, obviously you get the idea. We're gonna try to make an API call or download a model artifact from Hugging Face so that we can run whatever score that we need to run, right? Similarity score, semantic, whatever checks that we need to do. Step 3, 4, 5 are there to help you do that. For example, step 3, we want to check the content relevance. And then we actually have a model here. This model, you can actually go on Hugging Face and dig out that artifact. So for example, if you have questions, where does model come from? All you gotta do is copy it and then go to Hugging Face, and then you'll be able to find it. So let me click on that. That's the model artifact, right? And then here's a nice sentence here explaining what this model is doing. It's like, hey, look, it maps sentences and paragraphs to a vector space of length 768. And then you can then take that vector representation and do something else with it, right? For example, here I actually have a use case saying, hey, if you have a source sentence, this is a happy person, and then you want to compare that with 3 other sentences, like this is a happy dog, this is a very happy person, or today's sunny day, then all you gotta do is hit compute, and then it will compute these scores for you, so that you kind of get the idea, get an understanding of what this model is doing. And then you also have like sample code here. Oops. You also have sample code here if you want to make an API call or interact with this model programmatically. So that kind of gives you an understanding of what step 3 looks like behind the scene. So that's step 3. Step 4, check the facts. Here's a helper function that check the facts. So I'll show you what the function looks like. But basically, it's making an API call again to check the facts of the content of the user prompt. Same thing goes with 5 and 6. I'm not going to bore you guys with that, but these steps are all here, right? So once these steps are here, it calculates the final score, and then boom, there you go. You can just return that as a dictionary. So with that being said, now obviously I'll show you guys what that look like. Literally what I do is copy, right? Just hit copy, and then go to your Colab. Let me zoom in a little bit. So go to your Colab, and then if you scroll down, so you can run this function, and then you can type in a sentence of whatever it is that you just type in, and then you can put your URL here, and then it will give you an actual answer. Like for example, in this case, it says the domain trust is 60, content relevance is 56, fact checking is 50, and so on and so forth, and then the combined score is 48, right? You can then go to the search bar again, and then maybe find a different URL. You can copy that, and you can come back to the Colab, and then you can just put it here. It's a problem is the same because I haven't entered different question, but I'm now grading a second URL, right? Same thing. You can run it, and then it will give you a list of scores based on the function that we just said. And now you can see that this score is even lower. It's like now 29. Like earlier, it's like 48 or something. So now you kind of have a good structure of what this function needs to look like when you implement it. Does that make sense? Any questions?
Just the one B from Hugging Face to.
Yeah, of course. Of course. That's a good question. So let me come back up here. So this function on Colab, obviously, I'll give it to you guys. So the first submission, let's keep it simple, right? If you can just reproduce this and run it, and then you can just submit this script. I'll show you how to do that. If you just submit the script in the URL, then you're all set for the first deliverable. So at least you get a base understanding of what this function look like. Now, of course, if tomorrow you wake up, you're like, okay, I don't like this number 3. I think I think this model is just pretty bad. Like I tried a couple of questions, just doesn't work for me, right? Totally fair. You can use your own function. You can implement your own function from Hugging Face or whatever other platform that you found, and then you can come up with the same score. You can. So what's going to happen is depending on how you structure that answer. Let me give you an example. Like for example, you can say this model from Hugging Face, I don't like it for some reason. You can then take a different model from Hugging Face, but you do have to figure out how to interact with the model using Python. And then all you gotta do is update this chunk of code and come up with a different score, right? And everything else in the same script, you don't really have to touch it if you don't want to. So now instead of calling this model in your script, you'll be calling the model that you like. And then these 2 lines of code will be different from this code. But then everything else is the same, then that's perfectly fine. So the same function should be able to still work, and the structure is still there. Does that make sense? So any questions?
You want to use
Only for the first. Only for the first submission, unless you can come up with something better. Yeah, so something better means you have a different model or you have more features. You probably shouldn't have less features because less features are probably not going to be that accurate. I think more is totally fine. If you want to rewrite the script and then instead of having 5, you have 6 or 7 or 8, of course, yeah, you can feel free to implement it. Or instead of these 5, you then swap out some of these functions in the middle, and you have your own scoring system for that particular feature. Totally fair, no problem. What I'm giving you guys today is just the base level, like the absolute bare minimum. Like the next Tuesday submission shouldn't be worse than this. Does that make sense? Because if you just copy this and submit it, you'll be fine. So I'm talking about the worst case scenario. So that's a good question. Any other question? Good. Okay. So now let's talk about submission. So in terms of submission, again, depending on how you want to do it, and I'm going to give you guys the bare minimum version, right? The easiest version, right? If you want to go above and beyond, of course, you're welcome to do so. The easiest version in my head, literally, would just be you take this, copy, and then you go to your repo, whatever repo you want. In this case, I'll create a test1 repo just as an example. And then what I prefer to do is create a code space for yourself. So it has the cloud version of VS Code. So I already created one, and I click on that link. It will take you to like a code space that look like this. It's a VS Code window, but the difference is on the cloud, right? So you don't have to mess around with like tokens and set up with like the Git control, like things like that. So let me let's see. All right, let me show you guys what I mean by that is let me get rid of this function. And then let's see. I'm gonna remove the deliverable one because I'm gonna create a new one. So the way I personally like to do it is just to create a project folder. And then I'm gonna cd in there and then create another project. In this case, it'll be project one. So I'll just make my life easier, project one. And then cd in project one. And then here I'll call it deliverable one. So make directory deliverable one. And then I'm gonna go in there and then I'm gonna develop a code in here. So all I gotta do is now I can copy this and then, oops. And then go here, right click, new file. Literally, I'm just gonna say test.py. And then just paste it here. So this give me all of the base functions in here in one script. Now, here's the problem, right? This just defines a function, right? It hasn't been executed yet, right? So nothing's really happening here. Like if you do like a Python test.py, nothing will happen. I'm not even sure if it's gonna run because the package may not be installed. Yes, the package might not be installed, right? So you get questions popping up here and there if you execute the script inside VS Code. And that's not surprising because, well, here we talk about like here it has a list of packages that's being installed here. That's a requirement for the function to run, right? And then there's like API keys, Hugging Face tokens, things like that, right? So my personal recommendation is if you just run this Python notebook locally, or if you want to run on Colab, then that's it. That's perfectly fine. And then you can just download this and then upload on this directory along with the Python script. So does that make sense? So once you do that, I'm just gonna create a fake one just as illustration. So fake notebook, something like this. So once you have these two files, here is something tricky, which is to pack this together in a requirements file, right? Because if you use a package locally, I'm not assuming everyone will use a package locally, but just in case someone does, obviously tell me what package version are you using. So if I want to reproduce your code, I can do that, right? I can fact check the code that you created. Does that make sense? You can type in manually, but the way I do it is write a requirements.txt file for me using the following. If you just enter that, it will give you a requirements file that literally just like a list of names of packages spelled out. So copy that, and then you go to here, your directory, you say new file, requirements.txt. Just paste it down here, save it, and you're all set, right? Now you can just do git add. Let me make sure the directory is there. Right, so all the files are here, so you're good to go, right? Now you can cd to the main directory. And then you can say git add, git commit. And then make sure that messages is clear, right? At least say something like, I don't know, 2 words or something. Like this is deliverable 1. Like just so I know where to look, right? Hit enter, git push. This will push all the artifact from this terminal window to the public URL. So now you can go back to your web, the main page for test 1, and you can refresh, and then you see this. And then you have these nice messages here that's being committed. That's so I know which file I should be looking at. Does that make sense? Okay. now the rest of thing, the last step should be easy. Last step, literally just take this, or you can go to project one, take this, and then you go to your link. Where's the link? So let me find the link. Go to this link, and then down at the URL spot, you just paste that URL in there. Literally just do that. So I can go on to your project, go on to your folder, and look at the code you wrote, and then I can fact check it. So any questions? Good. Okay. Yes. Yeah. Yes, of course. Yeah, you can download a Colab. You don't have to run it in
Scripts and everything, so I just. So what if I just upload the idea?
You can do that as well, but make sure the requirements is clear. Yeah. Yeah. I had students submitting this notebook or submitting notebook as a homework before. I personally don't have a preference. The only problem is sometimes they will have imports that I don't know where they downloaded from. So without the requirements.txt file, I would have no way of verifying what these packages are from. Right? Are we talking about 2.0 or 2.1 or 2.2? Like without requirements file, I won't know that. Right. So sometimes create caveat situation where I run something and it's fine, and then students run something and it doesn't work, or vice versa. So yeah, it's totally fine if you want to do this. Just make sure you have a requirements file. Let me know what package you're using. Yeah. Okay, that's a good question. Any other question? Okay, one last thing I have to give you guys its API key. So obviously this is a public space, right? If you're gonna upload something on GitHub, everyone can see it, right? So please don't upload your API key in here. Don't worry about if I can reproduce the code without your key or anything like that. Don't worry about that. Let's say one of the functions, whatever. I'm just gonna pick a random one. Let's say one of these functions require a token or API key or whatever, right? All you gotta do is you say, put a comment here. I got the API key from, and then you just give me the link, and I'll figure it out myself, right? And for example, link is like if you go to Hugging Face, if you go to settings, and literally it's just here, right? So all you gotta do is take this. I don't even know. I don't even think in this case you need this because literally just in the settings and you go to access token. So all you gotta do is say Hugging Face website settings access token. That's it. That's all you need. Don't worry about how you can give me your API key or don't worry about any of that, right? Because I got an email saying, okay, well, they use a model here that requires a special API key, and then they don't know how to give me that. Don't worry about any of that. You just need to like put some sort of instruction here. I'll be fine. Any questions? Good. Okay. And then again, deadline for this first deliverable is next Tuesday before class. Good. Okay. Awesome. So any questions in terms of a deliverable? Is that clear? Okay. Okay. Good. Okay. I think we're coming up. Yeah.
Just option.
Oh yeah. If you can include unit tests, go for it. Yeah. Yeah, exactly. So that's a great question. So let me talk about that a little bit. So if you want, you can like whatever code that worked in your Colab Python notebook. I mean, in your case, you just submit a notebook. So I mean, it's pretty straightforward whether it's working or not working. In your case, if you want to submit a Python script and then like an execution script, right? So you can just take this and then somewhere here you can say, hey, I'm going to create a run.py script. Obviously, you're gonna have to do a bunch of import, right? From like you might need a helper script, something like that, import this function. Does that make sense? I think I call it test. Sorry. So from test import this. Does that make sense? And then you'll be able to have this, and then you can then execute this the script in the terminal, if that's what you want to go for. Yeah. Let me commit this. Run py script add-in. If you want to run in terminal, like for example, in this terminal or in your own terminal locally, you have to install the packages. Oh, I see what you're saying. If you want to do that, then you have to do it in like you need to have a main function, and then if name equals main, whatever, and then execute. Yeah, you can do that. Yeah. Like you can combine these two scripts into one script if that's what you're talking about. Yeah, totally. Yeah. I think in your case, the code will probably look like this is how we define a helper function, and then somewhere down here, you're gonna say something like if name equals to main, something like that. And then just whatever is happening here will be the execution. And then I think you just put this code here. You get the idea. All right. Yeah, so I got a couple of questions during the break. Just making a general comment. If you have your own idea, please go for it. We can always implement or iterate on it, no problem there. You can use what we talked about today in class as a baseline, totally fine, no problem, right? But if you have your idea of your own, certainly go for it. Okay, so that's it for project 1, deliverable 1. And again, deadline is next Tuesday, not today. Okay, so that's it for project 1, deliverable 1. And then now let's move on a little bit to slides. I want to kind of briefly go through logistic regression just so that at least we have some sort of, hang on one second, let me find it. Just so that like at least we can knock this out of the way. And then as we mentioned earlier, this is kind of like the most basic building block of machine learning. And then it also sets things up from like what do we mean by statistical machine learning? And then what do we mean by like machine learning, right? In the sense that linear regression has a closed form solution. Like if I solve a linear regression model, you solve a linear regression model, and then someone else solve a linear regression model, our answer should be the same. It has a closed form solution. Logistic regression, if the data gets too large and you use gradient descent, it's now dancing in between the line of like deterministic and non-deterministic, in the sense that if we all run a logistic regression, but we have different data and then we have different sample size of training data, and then we iterate on gradient descent different steps, you and I might get different answer, right? So that'll be something to worry about when you get to like you have a model, you fit the model against some data. Now how are you going to put it in production, right? Like how different your answers are going to be, like how robust your answer is going to be. Like it opens up a door for all those questions. And those questions very much lead you from classroom to the real world. So that's what I'm that's the goal for second part of the class, which is to give you guys those tools. Right. So very quick, number one assumption of logistic regression is we're talking about categorical variables that you're trying to predict, right? Like we're talking about like 1 star, 2 star, 3 star. Here's a caveat. When I give a 3 star on some Uber ride, and then you give a 1 star, it doesn't mean I like the Uber ride 3 times you like it, right? It doesn't mean that, right? 3 doesn't mean 3 here, right? 3 just means I give a higher rating. That's it. Like I like it better than you like it. It doesn't mean I like it 300% times as how you like it, right? So that's number one assumption. It's the numerical meaning goes out of the window, right? Just so we're talking in a sense of different categories, right? So that's number one. And then another terminology that you might hear people say is when you are predicting a model that the variable is categorical, it's called classifier. And then when you're predicting something that's continuous, like for example, stock price is continuous, temperature is continuous, sales number is continuous, that would be called a regressor. So regressive classifier depending on the type of variables you're trying to predict. There are a couple of famous examples that kind of provide you a motivation for why do you want to do linear regression. And here's like a couple of famous ones. Number one, a person arrives at the emergency room with a set of symptoms, right? And then it could be attributed to one of the three medical conditions. So that is a classic classification problem, right? Like we're not trying to predict any numbers. We're trying to predict which symptoms you are, right? Categorical variable. Number two, online banking. Um, like someone walked in the door trying to apply a credit card or whatever, and then you need to kind of come up with a scoring system to say, okay, he's probably going to be a fraud in the future, or he's probably not going to be a fraud in the future. Something like that, we usually consider that as a classification problem. Even though the score that you assign to fraud or not fraud might be continuous. Does that make sense? So that's a little tricky, right? The number kind of sound like a continuous variable, 0, 0 0.01, 0 0.02. But the problem is a classification problem, right? Fraud or not fraud. Okay. So number two is a little bit tricky, but I think if you look at the business problem, it should be very clear. Right. Number three, on the basis of DNA sequence, and the DNA sequence can be basically the genomic data of a certain patient based on certain disease. A biologist would like to figure out which DNA mutation have disease, have causality to a certain disease. So in that case, it will be disease or not disease. Obviously, that will be a classification. So typically when people think about these three problems, typically when people think about classification problem, these three problems are kind of like the famous ones out there that if you can like associate with any of these three use cases, then you got it. Then you got the gist of classification problem, right? Most easy one is like typically we write things out like this. Like if you're writing a research paper, instead of y in the real number, you will just say y equals 1 if something, y equals 2 if something, and so on and so forth, 3 if something. In the handwritten digit example, it will just be y equals 1 if a human look at the picture and the picture looks like 1, right? So what I'm like, the reason I say that is because these conditions are pretty much almost always come from human. Does that make sense? So classification problem is highly, highly dependent on domain expertise, right? So here's an interesting question. How could it possibly be the case that humans provide a label and we train models to benchmark against human performance, but then how come in some scenario humans perform worse than models, right? A lot of people don't get that. The reason is humans get tired. That's kind of it. These levels are determined by human, yes, but people miss out on the concept of not just any human expert. So the person who lists out these labels, like they better be expert of their field. Like we're talking about MDs, medical doctors with like 10, 20 years of experience. If they say this person's disease, okay, you can probably say, let's collect that as a label of this particular sample, right? And then when you train it, you predict y equals 1 if the person's disease, something like that. And then what's going to happen in the literature is they actually take that label and then compare that not against that original human doctor who provided the label, but against MD students who are still in school obviously the model is going to perform better because the students are trying to still learn what the professor is trying to do, right? So there's a little caveat there. That doesn't mean model is beating human. It just means model is beating some humans. Does that make sense? When you say humans, like you're talking about everybody, like 8 billion people on the planet. No, that's not what that statement means. So just want to give you guys a note of where that caveat come from. When you see the news, how do you interpret the news? It goes from who provide these labels. Any questions? Yes. It's useful to meet both people. Yes, exactly. You brought up a very good point. So the person who tell us whether this person's disease or have a stroke or whatever, obviously they're expert of their field. We respect that. We collect the data. Great. But here's the problem, right? It runs into ethical dilemma. Doctors want to make money, right? You're not gonna go to 10 years of medical school and not be a millionaire, right? You're shooting yourself. You're shooting yourself in the feet, right? Why do you want to do that? But to be a millionaire, to make money in medical space, you need to be the very few people who own that knowledge, right? Why on earth do you want to provide the label so that some computer scientist doesn't even know medical knowledge can reproduce what you learn 10, 20 years in the domain? That makes no sense. Why do you want to do that? So it takes a lot of fight in between computer science and the medical domain to get that label out of the medical experts, right? So again, this is kind of like a long answer of is machines beating human? Is human beating machine? It doesn't really justify that kind of level of questions because we're not talking about same, like when the news saying beating the humans, they're not talking about same humans that's providing a label, right? So that's how you argue about this kind of things. And then basically the mathematical form is, who said you have a stroke? Is a regular human or is a MD with 20 years of experience? Cool. So in terms of graphical interpretation, this is the standard graph that you kind of have to understand. On the left-hand side, it's a plot of same data, but with a linear regression model. Linear regression model means the blue line here, and blue line is a straight line, and hence is a linear regression model. Now, you get the idea that there's a lot of caveat here in the sense that linear regression takes all of your features and map onto a real line, right? Real line basically means, let me annotate this a little bit. Real line means this line. And then it can go from minus infinity to positive infinity. And usual case, that's fine, but in this particular case, that's overkill, right? Like I don't care about minus 10. Like I'm talking about a probability of trying to classify if this person's disease or not. I don't care about minus 10. I don't care about plus 20. That has no give of the business problem that I'm trying to understand, right? So how are you gonna do it, right? How do you turn this, and then whatever extended up here, like how do you gonna turn this, and you bend it in a way such as it's S shape, and then now it's bounded in between 0 and 1. So that is the function called logit, and the logit function help you do exactly that. So logit function will take any straight line and bend it, the top side and the bottom side, so that it's bounded in between 0 and 1. And then the minute you do that, now you mapped every single combination of what a model predicts onto only this range, which is from 0 and 1. And then 0, 1, it's interesting because now it's a probability, right? Like I heard people say 200%. That's not a thing here, right? There's no 200%. I commonly hear people say, I'm 200% confident that stock market is going to go up. Well, first of all, you don't know that. Second of all, 200% is not a thing. Like it can't be defined here. Like if you take probability theory, the first thing they're going to do is they teach you how probability is defined, and the first thing that they tell you is the range of that function is 0 and 1. So you can say 0%, meaning that you're not confident at all, right? Zero chance is going to happen. Or you can say 100% or 1. means you're very confident, right? Or anything in between. 2 is not a thing here, right? And hence, that's what the function is doing for us, which is to help us mathematically map that function into a domain that we could possibly interpret. I can show you a function right now. It's actually a pretty good thing to know. Let's see. I can go to a browser. You can probably just graph it here. You can say y equals to y over x. Let's start from there. Let me zoom in a little bit. It's kind of like curved like this. Now you can say 1 plus exponential minus x. Now it's S shape. So the difference is whatever this x is, you can kind of think of this x as a combination of different features. Like for example, y equals to let me use different features. Let me say z equals to 2x. Let's say we're looking at a very simple linear regression model, just straight line 2x. Let's throw in bias. Let's say something like this. Move up a little bit. There's a 1 here that's intercept. Let's say this is a linear regression. And now what you're doing is you're taking the z, which in this case it's just a whole line. It's just this whole line. Now you're throwing the z in here, and then you just call it x. Or you can do I don't know if this works. Yeah, z also works. It's just the x-axis now is called z. Does that make sense? So everything coming out of a linear regression model, you just gotta throw in this formula, 1 over 1 plus exponential minus z. You'll be able to basically reshape it into this shape. And then the interesting thing about this shape is now everything is bounded in between 0 and 1. Any questions? Okay. That's pretty much it about like what's going on in this picture. Now let me take you to this kind of formality. Personally, I think this kind of formality is difficult to sell in the real world. I don't think anyone's using that terminology anymore. But if you write a research paper or if you want to do a PhD, people still use this kind of terminology, right? So the right terminology of understanding logistic regression model is to use conditional probability, right? So conditional on what are the features that you observe, what is the probability that this patient is the default case. So that is what this formula is saying. So again, this bar here means conditional probability. And then another thing that ties up with conditional probability with logistic regression is how the model is trained. So if you go to stats class, you might hear people say log likelihood function. So the log likelihood function is going to be the way to solve for the model if the model is written this way in terms of conditional probability. In this class, we're not going to go to that level of detail. You have stats class to do that. But I just want to tie up the string. So when you look at this, you're not like completely lost. Like, they're talking about the same thing. Great. That's another way of writing it. It's the same. This formula, it's the exact same thing as what I just wrote. If you just take the top part of the fraction and divide top and bottom, the same thing, and then this top the numerator of the fraction is going to come up to be 1, and then the bottom is going to this part is going to cancel out, and then this 1 is just going to be minus. So that's why you get an exponential minus z or whatever the linear model is. That's kind of it. Again, another way of writing it is use this formula called logit. This is also called log odds. Log odds is kind of based on the odds ratio, and the odds ratio is defined by probability of x versus the complement of that, right? For example, what is the probability that you get that you are diseased over the probability that you're not diseased, right? So p over 1 minus p. What is the log of that? The log of that is going to be the linear regression model. So that's another way of interpreting or writing the problem. It's just with a different format. Okay, so this this function on the right-hand side, this is called the likelihood function. Again, stats, this is all stats content. You don't have to solve it. You have stats class to teach you how to solve it. But this ties things up between statistics and today's ML, which is more like an iterative training process. But in the stats world, the way you solve logistical regression is you set up the likelihood function and you try to maximize it, right? And then this likelihood function actually very interestingly can be written that look like a cross entropy. And cross entropy is the loss function that goes into TensorFlow model, torch model, things like that. And this is a mathematical form of that. Again, you don't have to solve it completely, the packages do that for us. And I can show you guys a demo of what that looks like. This is the results of a logistic regression model. I'm going to quickly walk through what this means. It's very similar to a linear regression model in the sense that obviously you have coefficient because a linear regression model has a coefficient. Obviously, logistic regression model has a coefficient. You also have a standard error, and then the interpretation of standard error is you want the standard error to be small in scale in terms of a coefficient, right? So that if you run a z-test, z-test means you calculate the z-stats, and then the coefficient over standard error should be as large as you can. The larger you can, the easier you can pass hypothesis test, and then the more significant this coefficient is. It doesn't answer all of the questions, but it's one interpretation that helps you just be a little bit more confident of the features in your model. And then how they play into the equation is if you write it out, you write the coefficient just like a linear regression model. And then whatever the linear regression model is, you just throw that in all the exponential thing that you saw earlier. And then that will be this will give you a probability, and the probability will be able to tell you based on this features, based on your data, the probability that this person falls into that class, that category is whatever. 10%, 20%, 30%, so on and so forth. And this pretty much unpacks everything inside of a logistic regression model. So what I want you to take away from here is you should be confident to say, okay, we as a human being knows everything about the logistic regression model. Like you shouldn't say logistic regression model is still a black box, and it's not a black box. Like we know every number in here. So that's what I want you to take away from this. And then I think there are a couple of other things. I'm going to leave it here. I'm not going to go through this. I'm going to use the rest of the time to implement it for you guys. So let me take you to TensorFlow. Here. I think some of you, I think I showed you guys this earlier when we were talking about linear regression model. We're going to go through everything just so that everybody is comfortable with this. This does come up in interview. I've got an interview that people literally ask me to like they will blank out some of these. Like for example, they will do this, and then they will ask me to type things out in terms of Python syntax. So that's why I have this here, just so that hopefully if you guys get similar questions in the interview, hopefully you guys all ace that interview. Let me. I'm sorry, I don't think I'm recording. So I want to. Let me start recording. Okay, I want to spend a few minutes walking through the code. I think I'm gonna guess most of you guys probably already seen it before. So I'm gonna quickly go through it just so at least we're all on the same page, just in case someone has not seen it before. How do you do a logistic regression using TensorFlow? Right, that's what this code is showing you. Well, first things first, you need a data set, right? Some sort of data set. And then for the time being, I'm gonna use housing data as an example. The reason I use that is because you guys are gonna have to create your own target variable, right? So we talked about housing data before, and if you run ahead, it turned out it's a regression problem in a sense that these are dollar amount, right? They're not category 1, 2, 3, 4, right? So dollar amount actually means something, right? The 66,000 is of course less than 80,000. So it's up to you to define what category we're talking about here, right? And I picked this case in particular because I want to show you how you pick the target variable affects the accuracy in the end after you train the model, right? So number one, you read the data, and then that's the data look like, and then immediately you're gonna have to define your x, define your y, and then get a shape so that you can have a gauge of how big the data set is. And we talked about this earlier before. You want this number to be bigger than this number because you want to have more sample size against the feature size that you can have, right? Otherwise, you're gonna run out of sample and then you're gonna overfit, right? So you want as many samples as you can to learn as little feature as you can. Right? So you want this number to be larger than this number. If someone give you a data set that's not that, it's up to you to figure out how to massage the data so that it looks like that. Does that make sense? So that's where data engineer comes in. Anyhow, number one, very easy, just a linear regression model. So let's walk through that. The syntax is just set up a sequential API. Whenever you see this dot sequential, in TensorFlow, this is called sequential API, right? It has nothing to do with sequential model, right? I don't know why they call that. It's super confusing. I did not come up with the name, right? TensorFlow package is developed by Google Brain, and then for some reason they call it sequential here. It's not a sequential model, right? Sequential model means recurrent neural network. It's not a recurrent neural network, right? Sequential here is referring to the style of this level of API, right? What that means is the layers are added layer by layer. In other words, you're adding layers sequentially, right? What unfortunately what that also means is you cannot have a divergence in the layer and you cannot converge. You can only do that using functional API. Does that make sense? We're going to talk about functional API in the future, but for the time being, if you're just building something as simple as a linear regression model, you can just get away with dense layer. Dense layer will take all these 8 features in, and then basically do a linear combination, and that's it, right? Notice that here I did not specify the activation function. Where's the activation function? This one. So the default activation is none, meaning that there isn't any. So if there isn't any, it's just a linear regression output. Of course, if it's a logistic regression, obviously you need to change that, right? So you can compile it, and then you can run it. And then compile it, this is the area when you specify the optimizer. Like, for example, if you want to run Atom, you just write Atom here. The last function will be MAE. In this case, it stands for mean absolute error. Okay? Or you can use mean square error if you want. They're kind of the same. Same thing. You train a model. Here, you throw in your X. These are features. You throw in your Y. This is a target variable. It's the housing value. And then it gives you this nice thing that I didn't know it has before. I think recently they update this, and then you can actually see a distribution. So kind of nice. So right off the bat, you can kind of say, you don't want to, like, if you're going to create a target variable, you obviously don't want to have a cutoff here, right? Like I've had people do that, and that's not going to be good, because what's going to happen is you get like a 90% of the situation that's class 0, and then like a 1% situation that's class 1. So it's unbalanced. If it's unbalanced, model is going to guess all zeros, and then get 90% accuracy. But then guess what? 90% accuracy doesn't mean it's good. It just means you have imbalanced data, right? So validation split, it's the ratio that you use as a validation set. It's basically a carve out set if you want to do fine tuning. And typically we have this set as maybe 10, 20%. Now, of course, depending on your sample size, if the sample size is like tens of thousands, then you can do whatever you want, right? Because you have enough sample size to play around with different ratio. If your sample size is like 100 or like 500, then obviously you should probably stop at that point. Or you just maybe set a smaller ratio, 0.01 or 0.05, so you can carve out more samples for training, right? I think in this case, we don't have a problem, so you can pretty much set whatever number there. Epoch is the number of iteration. Again, don't ask me why this is the case. I think this comes from French. I don't really know why they developed this model based on French language. But I think in French, this means iteration. So when you hear people say epoch or EP, that means iteration. So this is the iteration that you run the gradient descent. Based on iteration, the more iteration you go, hopefully the loss is smaller, right? Which means this number need to get smaller. If you go to this and this number is going bigger and bigger, then you have a problem. So it's just something to watch out for. You can save the model. I'll leave this here. I'm not going to run it. You can save the model however you want. I leave this code here just in case that sometimes people run this model. The model, like if you run the model, that we can check this right now. It's going to be a small model. Like, oh, I have a code here. So if you run a model of summary, it's going to print out how many parameters that the model is trainable. In this case, not a whole lot, right? You have 8 features. You have 8 features, and you have a bias. So altogether, the trainable weight is 9. So pretty straightforward. We're updating 9 numbers, not a whole lot of numbers. So you can kind of get away with whatever. In a case that, like, if this is a GPT-2 model, this number will probably be in the billions. So you're not gonna train this locally. Colab is just not gonna run, right? You press a button, it's just gonna crash. Or sometimes I've seen people train a model that's hundreds of millions of parameters. They'll probably train like 2 epoch, and then the code will crash, right? So in that case, this is when this line of code come in handy, which is instead of running this line of code model.fit 10 iterations, what you're going to do is you set this as 1 iteration, and then after it's done, save it immediately. And then when you save it, obviously save it in your Google Drive so that you never lose this file. So that would be a hack to get away with like this subscription, like what I have here, Pro Plus. You don't want to pay for that, right? If you don't want to pay for that, then this code is going to save you some money. Does that make sense? Exactly. Yeah. Yeah. So like if you hear like you hear the news DeepSeek is out there right now, right? I don't have to tell you what this is. If I have 1 layer or 2 layer or 5 layers, I don't really have to tell you what that is, right? I can just save this as an H5 file, and I just send that file online, and you can download it, and then you can run the model without knowing what I'm doing. Kind of like you own the model, right? Yeah, and then you can kind of like reverse engineer. That's here. And this line of code does that for you. So once you have that, once training is done, you can make a prediction, and then you can test out prediction. I don't know why I'm plotting. Oh, scatter plot. So scatter plot in this case probably not that helpful because they don't look like a line. So linear regression is probably not going to cut it. So that's what this plot means. So it's pretty ugly. Like I don't see any pattern here whatsoever. So I'm going to skip that. Let me take you to this model down here. This is the famous model by Yan LeCun. It's a standard data set for you to learn a neural network model. I'll quickly walk through this, and I want to show you what the syntax look like in terms of a classification setup. Just so you can compare. Last time we talked about linear regression, which is regression problem. Today we talk about classification, which is classification problem, how different that can be. So right off the bat, you download data, and then it turns out the data is high dimensional. High dimensional means there's a width and height, because these are picture data, and picture has width and height. Now you get away with this is a black and white. So that's what these pictures are created from. You get away with not using the color, right? If you're gonna use the color, there's gonna be a secret 1, secret 3 here, because color in computer science is RGB, red, green, blue. Here it's just black and white, so we don't have to worry about that dimension, right? So once you have that, a hack that I typically tell people is this line of code will probably save you a lot of trouble if your data is large. Like I've had students come in, say they process data, it took them 5 hours to process data, and then Colab crash, and then they like cry for 5 hours. When that happens, just use a pickle dump, and then you can dump everything in a .pickle file. When I say .pickle file, I'm talking about something like this. Then you can kind of save everything on the spot. Does that make sense? And then after this, let me just show you. You can of course load it back, right? Same procedure. And then let me just show you a syntax. The syntax. We're gonna walk through this when we get to the deep learning part. I just want to quickly show you a syntax. Where's my syntax? Here. So these 3 lines of code, it's a little bit of update from previously. Previously, we have model.add, literally just .dance once. This code here, if you want to have more layers, you can just copy this line and then just literally just put it down here. And that'll be 1 more layer of neural network model. And do the same thing, put it down here again. You have 3 layers. The main thing that differs your model in TensorFlow setup from regression problem to classification problem is this final activation function. If the activation function is sigmoid or softmax, it will be a classification problem. We're going to talk about the math behind this maybe next time. But for now, you just need to know that if you go from regression to classification, pretty much everything is straightforward, is the same. The only thing that's different is this one. And after that, you can compile it and fit the model. I think I have some code here. Compile it, and then fit the model by using model.fit. Here, model.fit, and then that's it. The other stuff that I skipped today, don't worry about that for now. We're going to come back to this in the future. I just want to show you in terms of TensorFlow portion of the code how different things are. Okay, I think I'm gonna stop here because that's enough content for today. And then, yeah, so for this week, just want to reiterate the deliverable for project 1. Deliverable 1 is next Tuesday, right? And then feel free to do your own thing. If you already have a model going on, feel free to do your own thing. But of course, you can take what we talked about today, which is this code here that we talked about. If you want to use this, perfectly fine. You can also use your own.